In this video, we are going to find the inverse of given functions. The process involves interchanging x and y. So the first step is to rewrite the part that says f of x as y. So we'll rewrite this as y equals the cube root of x plus 4. All right. Step 2 is to exchange x and y. Remember that inverse functions are reflections across the line y equals x. After we find the answer here, we'll go look at Desmos and see that. So I'm going to exchange where x and y are. So I'm going to write that x is equal to the cube root of y plus 4. Now what I want to do is solve for y. I want to get y by itself and everything else on the other side. So I will go ahead and cube both sides of this equation. So then we'll have x cubed equals y plus 4. And then we can subtract 4 from both sides. And we're getting x cubed minus 4 is equal to y. And then the final step is to rewrite y as f inverse of x. So this is our answer. F inverse of x is x cubed minus 4. Let's go take a look at Desmos and see how these two graphs look next to one another. So the dashed line that I have here is the line y equals x, and the original problem that I had was x plus 4 raised to the third power, which is the same as the cube root. That graph looks like the blue graph here. And then the one that's down below, this is the inverse function that we found. And you can see that these two are reflected across this line, the green line. I can kind of verify here one of the points is negative 4, 0. And the point here is 0, negative 4. We can see that the x and the y coordinates have interchanged with one another. Another place to look might be here. The x-intercept here looks 1.58, and then up here that'll be the y-intercept. So we can see that the x and y values have interchanged. All right, let's go back and do some more examples. For example B, we will start by rewriting f of x with y. And then our second step is to exchange where x and y are. And then we want to solve for y. So I am going to take the square root of both sides so I can get rid of that square on the right-hand side. So I've got the square root of x equals y minus 4. Then we'll add 4 to both sides. And we're getting that square root of x plus 4 is equal to y. And then for our last step, instead of y, we'll write f inverse of x. All right, so this is f inverse of x equals square root of x plus 4. In the example that we did a minute ago, let's go back to example A for a second. The domain of our original function, the domain of square root of x, of f of x, which was cube root of x plus 4, was all real numbers. There are no restrictions when we plug numbers into a cube root because we can take the cube root of negative numbers. And the range was the same. The range was also all real numbers. When we find an inverse function, the domain and the range switch. So when we look at our inverse function, which was here, the domain is all real numbers and the range was as well. It's hard to see that there was any exchange because both of them are all real numbers. But in the example that we're doing here, we do have a restriction on our answer that we're getting. If we look at this function here, our x values need to be greater than 0. We can't take the square root of a negative number. So the domain here is that x has to be greater than or equal to 0. And because of that, when we were going to think about finding the inverse of that original function, we needed to restrict the domain. Our original function is a parabola that is sitting at positive 4, so it's sitting like this. And we know that this function is not one-to-one. So what we needed to do was get rid of half of this and only take the part where we were saying that our x values were going to be greater than or equal to 4. By doing that, that will allow this domain to be restricted on the inverse function. Let's go to Desmos and take a look at this. It'll make a lot more sense when we see the picture. So the original function that we had was this blue graph here. Again, this is half of the parabola. You can see that we've restricted to take x values that are only greater than or equal to 4. And the reason for doing that is that when we reflect across the line y equals x, we can see that our square root graph is beginning at y equals 0. So the domain for our inverse function is 0 to positive infinity. The range is going from 4 to infinity, whereas from our original function, the range was 0 to infinity. That matches the domain of the red. And the domain is from 4 to infinity, which matches the range of this one. So the domain and the range of the original function and the inverse function swap. For this example, we are, similarly to what we did in the last problem, we're going to restrict the domain. We're going to restrict the domain to be from 0 to infinity. We do that so that we make this function one-to-one, and then that way when we find the inverse function, we can have a restricted domain. I see that the original here is squared, so I'm thinking that my inverse function is going to have a square root. So step 1 is to write y equals 2x squared plus 4. And then I will exchange x and y. And then I want to solve for y. So let's start by subtracting 4. Then let's divide by 2. And then we'll take the square root of both sides. So we're going to say that this is our inverse function. I'm going to write it up here. F inverse of x is equal to x minus 4 over 2. All right, we know that that what's underneath the radical symbol, what's underneath the square root, needs to be greater than or equal to 0. Let's see what's happening here. We need x minus 4 over 2 to be greater than or equal to 0. That's to ensure that we're not taking the square root of a negative number. If I multiply both sides by 2, I'll have x minus 4 greater than or equal to 0. And it looks like I need x greater than or equal to 4. So, oops, 4. Let's go look at the graph in Desmos and see how this works out. So again, our original was 2x squared plus 4, and we restricted the domain to be only greater than 0, so we would have just half of that parabola. And you can see that the y-intercept there is 0, 4. That's matching up with what we saw, what the necessary domain was for restricting our x values to make sure we're not taking the square root of a negative. And you can see here that this domain is going from 4 to infinity. So again, x and y are switched, and the domain and the range are also switched. The only time we need to think about restricting the domain is when we have something that's either a square or a square root, because we're not allowed to take the square root of a negative number. But in this example, we have something cubed, and so we think that the inverse function will have a cube root. Those two types of functions do not have restrictions on their domains, so we don't need to worry about any of that because we'll just have all real numbers as both the domain and the range for this problem. So we'll start by rewriting y equals 4 minus x cubed, and then I will exchange x and y, and then solve for y. I'm going to move this around. I'm going to move the y over to the other side and the x to the other side, just so it'll be positive. Y cubed equals 4 minus x, and then we'll take the cube root of both sides. So I'm getting that y is equal to the cube root of 4 minus x, or f inverse of x is the cube root of 4 minus x. And again, no domain restrictions on these. Let's look at the graph in Desmos. For the example that we just did, here is the original. The blue graph is the original. And then here is the inverse that we just found. And as I mentioned, both of these functions have all real numbers as both their domain and their ranges. Let's look at the x-intercept here. It looks like it's 4, 0, and the y-intercept here is 0, 4. So we can see those x and y values exchanging. For example E, we're starting with a square root as our original function. Let's think about what the domain of this function is. For the domain, we need 3 minus 4x to be greater than or equal to 0. If I'm going to move the 4x over, so 3 will be greater than or equal to 4x, and then I'll divide both sides by 4. So 3/4 is greater than or equal to x. So this is my domain. I need x values to be greater than or equal to 3/4. Let's find the inverse function. We'll start by writing y equals the square root of 3 minus 4x, and then we'll exchange x and y. And then I'm going to square both sides to get rid of that square root. So x squared equals 3 minus 4y. I'm going to switch the sides of these because I want to make the y positive. This will go over here and this will go over here. So we'll have 4y equals 3 minus x squared, and then I'll divide by 4. So our inverse function, f inverse of x, equals 3 minus x squared over 4. Now, our original had a restriction in the domain, so we're expecting that the range for this one is going to be that our y values are greater than or equal to 3/4, right? Because our domain and range should switch. But we also know that because this final answer here is a quadratic, we're going to have to restrict the domain here because the square root graph is only going to be half of the reflection of the square root graph. Let's look at the graph to help our understanding of this. So here's our original function, the square root of 3 minus 4x, and as you can see, the y-intercept, or sorry, the x-intercept is 3/4, and all of our x values are less than or equal to 3/4. The answer that we got for the inverse function looked like this, and you can see that it's a parabola, but it's got more space than the actual reflection. We don't want this other part that's to the left. So for our final answer, we need to restrict the domain to take the x values that are greater than 0 only. The other way we could have known this is by looking at the range of our original function. The original range was y values greater than 0, so the domain of our inverse function needs to be x values greater than or equal to 0. So back here at our answer that we got, we want to say that the domain of this needs to be x greater than or equal to 0. All right, one more example. This one's a little bit more difficult because we've got a rational expression where we've got x's in multiple locations. So it makes the solving just a little bit more complex. We still follow the same steps where we will exchange y for f of x. And then I'm going to rewrite x in the place of y and y in the place of x. All right. Now I want to clear the denominator, so I am going to multiply both sides by 5 minus 4y, that whole entire denominator. Let's move this over so I have more room here. 5 minus 4y. So this is going to cancel with this, and I'll have 5 minus 4y times x equals 3y plus 4. Now here's the trick. What I need to do is get all the y's on one side and the x's on the other side. So I've got to multiply this x through both of these terms so that I can put everything with y on one side. Let's multiply this out. This will be 5x minus 4 times xy. And then the right-hand side stays the same. Now I want to take anything that has y and put it on the same side, anything without y on the other side. Let's move over here. So we'll have 5x minus 4, and then we'll have 3y plus 4xy. I just moved all the y's onto the right-hand side and anything without a y onto the left-hand side. Now, this is the part that's helpful, is now because the y's are all on the same side, I can factor that out of both of the terms. So I'll put y equals 3 plus 4x. And then I can divide both sides by this 3 plus 4x to get the y by itself. Because we started with a rational function, we're ending up with a rational function as well for our answer. And then for final step, rewrite f inverse of x in place of y. All right, let's think about the domain and range issues here. The thing with rational functions is that we have asymptotes to consider, right? So looking at the original function, our denominator can't equal 0. So it looks like x cannot equal 5 over 4. For our final answer, for the f inverse, we have 3 minus 4x that can't equal 0. So x can't equal 3/4. Let's keep track of those numbers as we look at the graphs to see what happens in our final answers. All right, before we go, I see a small error that I have here. Right here, I changed the plus to a minus. So let's go back and fix that. This should be a plus. This should be a plus. And then, so it's messing up our domain here. Let's do this again. 3 plus 4x cannot be equal to 0. So 3 cannot be equal to negative 4x. And so I should get a negative 3/4 not equal to x. When I went and looked at the graph, I saw that I had a small error, so I wanted to just come back and fix that before we go to Desmos. All right, let's first look at our original function, which was this. I can see that I've got both a horizontal and a vertical asymptote for this because it's a rational function. And then this might be a little bit hard to see, but here's our inverse function. Sometimes it's a little hard to see that's like actual inverse, and so what I like to do is pick some test points to look at. It looks like this portion of the graph is reflected with this portion, the two parts that are closest to the line y equals x, and then this part is reflected with this part. So if I look here at the x-intercept, I get 0.8, and that should match up with the y-intercept here. Yeah, it's 0.8. The other two parts of the graph, they're where they don't have other intercepts, so there's nothing really for us to grab onto to look at. Now, as far as the asymptotes are concerned, let's look at one graph at a time. I'm going to actually turn this part off. I'm going to turn that line off. Let's just look at the original graph. The original graph had a horizontal asymptote, a vertical asymptote of x equals 5/4 and a horizontal asymptote of x equals negative 3/4. Notice that when we go to look at the inverse, the horizontal and the vertical asymptotes are going to swap. So the horizontal asymptote here is y equals 5/4. That was the vertical for the other one. And then the vertical is negative 3/4, which was the horizontal for the other. So for these rational functions, not only do domain and range switch, that ends up showing up in the asymptotes because those are the portions that are removed from the domain and the range in those types of functions.